Hi, I'm Bob Allison with ShopSabre CNC. Around here they call me Router Bob. We offer monthly training classes on CNC here in our facility in Lakeville, Minnesota that are very highly related, and we're going to continue to offer those. But we decided to create a virtual version of this class for people who are a bit apprehensive about travel at this time. The instructor in the class will be Logan Poppy from our support department.
Hi everyone, I'm Logan. I'm a technician here at ShopSabre, and we're going to head out to the machine and take a look at our ShopSabre controller. First thing you'll notice on the controller is that all the axis letters are red. That means that you have to home the machine. So when you hit the home button, which is located right here, the axes will start moving and it will go to find home. Now in this case, we're not at the machine. This is a demo version, but what you'll end up seeing when it's all done is that it'll move all the way forward, touch its limit switches. If you notice the little dots coming forward, it'll touch off its limit switches, back off to the home location, and it'll end up calling that the home position. Right there. Now we can see the X, Y, and Z axes are all 0. At this point, you'd be free to drive the machine around, and you can do that using either the arrow keys on the keyboard, page up and page down for the Z-axis, or you can use these arrows on screen here as well. And you can see if we try to go too far, it's going to give us an error, soft limit high Z, or soft limit low X, or high Y, whichever direction we try to go. So that means we've exceeded the cutting area on the machine. We can't go any farther than that. You'll see the coordinates move on screen as you drive it around, and the little dot there is the center of your spindle. Wherever the spindle goes, that's where the dot will be. You can also use multiple axes at the same time. If I hold both the left and right arrows, they'll both move at the same time. Up here, right next to the coordinates, you're going to see the speed that the machine is going to travel. Now in this case, the default for this machine is 800 inches per minute, but you can increase that or decrease that based on what the program that you're running is telling it to do. So in this case, we can go up to twice as fast, or the limit of the machine, which in this case is 1600, or down to 1% as fast. And we can increase or decrease that 1% at a time. Every time we hit the insert or delete key, it goes up or down. And the control insert is going to bring it back to 100%. And you can do that dynamically as you're cutting. So you can start a little bit slower and work your way up as you realize that the bit can handle more speed. You can also do the same thing down here with the spindle. On the far right side of your keyboard, the number pad has a plus and minus. Every time you hit the plus, that's going to add 1% to your RPM. And you can do that again dynamically as the machine's cutting. So if you realize it's starting a little bit too slow, you can bring it up and listen to make sure the bit sounds like it's doing well at that speed. Now, if you don't have the RPM slider bar, you can change that RPM on your VFD, or if you have a Porter cable router, you'll have a slide bar on the Porter cable. And that's also an upgrade that you can purchase and add on to the machine in the field. Up on the very top here, above the coordinates, you'll see it says G54. For most people, almost all the time, you're going to be running in G54 mode. And that means it's at the primary head. So for most people, that's the spindle. If you happen to have a secondary head, a tangential knife, creasing wheel, boring head, something like that, you're going to have a G55 or 56, and you can switch between them by doing G55 or G56 in the command bar here. Anytime you want to enter a command, you can just start typing it in here and hit enter. Now in this case, we can see it's switched over to G55, and that's our W axis. This machine is set up with a boring head. To switch back, we can also do just a G54. And when we do that, if we have a coordinate, we'll have a coordinate shift if we have an XY0 set as well. We can also, in that same command bar, command the machine to move to a different position if we want. So we can type in X10 or Y20, and you're going to see the red dot move there. It's going to move to those locations. If you do a G53, X10, Y20, it's going to move that distance from the home position regardless of where you've set your XY0. Now in this case, our XY0 is our home position, and that's going to be true if we're using pop-up reference pins, which you can see right here. If we were to hit that, it turns blue, and our pop-up pins would then come up out of the table, and we could push our material right up against that, and that would be using our home position. If we didn't have pins or we didn't want to use them for some reason, we can move it where we want it to be, move the center of the spindle, usually to the front left corner of the sheet, but there are some times when you might move it somewhere else. And then once you're there, you're going to hit the XY0 button. You can see the coordinates go green, little green boxes next to them. And if you hit those, they'll turn red. And that means now you're viewing the home coordinates, but relatively, it's going to be showing the XY0 coordinates. So now if I move it, you can see it's moving relative to this orange crosshair. And this orange crosshair is your XY0 coordinate. Normally you won't see them because they'll be right at the edge of your cutting area. This red box is the cutting area of the machine. So if for any reason the program tries to go beyond that, you're going to get one of those soft limit errors. On the preview screen, you can click to zoom in. That's a left click. You can right click to zoom out. You can also left click and drag a box, and it will zoom into that area. And if you hold the control button while you click, it'll pan around at that same zoom level. And down here are the coordinates of wherever the mouse is at the moment. So if I put that over the spindle, it's approximately 9.7 by 9.9 inches. A lot of times that'll be really useful if you've got material that you're not quite sure if it's going to fit, if your program's going to fit. You can move the spindle to the edge of the material and see, once we start previewing our drawing, see if that fits in that area. Or if I move my mouse to the edge of a preview, and we can look at the coordinates and see if they line up. Also up here by the coordinates, we have a drop-down list that has P positions and H positions. Now by default there's 10 of each. Usually that's more than enough, although that can be added. We can add more to that. The P positions are just a location around the table that you might want to go sometime. So usually we'll use one for an unload position at the back of the machine, and another one for a position near home for when we want to shut it down. Because remember, when we home it, it's going to take a while to come all the way forward because it doesn't know where it is. So we want to be somewhere near the front left of the machine when we shut it down, just to make sure that we're not spending a lot of time homing. So to set one of those, we can move the machine where we want it to be, select our P position, hit edit, and we can hit get position. Now what that's going to do is fill in these coordinates, and typically I'm going to delete any vertical axes out of there. By default, it's going to lift up, run back to that position, and then if there's a coordinate in Z or W, it's going to then move the Z up or down to get to that location. So if we have that blank, it won't move up and down. We can also give it a name if we want. So now let's say our program is just finished and our spindle's sitting right here. We can come up to P1, click go. It's going to lift up and it's going to run back to that location. Now the spindle's out of the way and I can load my material and I can run the program again if I'm just running the same part over and over. The H positions are similar, but they are also going to set an XY0 at that location. This is really useful if you have jigs that are set up on the machine. So if you're running the same 2 or 3 parts over and over and they have their specific place on the machine that they're set, you could have an H1 there, H2 at the next one, H3 at the third one, and you can easily switch between them by just selecting them and hitting go. So for instance, if I move this here, edit, get position, and I could give it a name, and then I hit go, if I'm somewhere else and I hit go, it's going to move back to that location and you can see the XY0 changed. So that's now my 0 point. And these will permanently save. When you close the controller, shut down the machine, it's going to remember these for the future. So anytime you come back to them, they're always going to be in the same spot. And that's really helpful if you've mounted your jigs to the tabletop. Fourth axis is another good example of this, where you might want to take the fourth axis on and off the table and always want it to go back to the same spot so you don't have to reset your 0 every time. This is a great way of doing that. At the very bottom right corner, you see it says G90, and that's the mode you're most likely going to be running in almost all the time. G90 means it's referencing the absolute coordinates on the machine. So if you are telling it to go 10 inches from 0, it's going to run 10 inches from 0. If you're in G91 mode, you tell it to go 10 inches, it will move 10 inches from where it is at the moment, and every 10 inches after that will continue to move. Whereas with G90, it won't move again because it's already at 10 inches. The next thing it shows is G0, and that just means what type of movement you're doing. A G0 is a rapid movement, G1 is a feed rate movement, and a G2 or 3 are an arc radius movement. Tool 2 is what's shown in the spindle right now. If you have a tool changer, you'll have this box there. One thing to note is to always make sure that that tool matches up to what tool is inside the spindle. If they mismatch, you could get a crash as it tries to put a tool away in a spot that already has a tool, or vice versa. If you have no tool at all, it's going to say no tool right there. At the bottom left, it's going to show the very last directory that you've run a file out of. Always make sure you're running off the C drive. It's okay to transfer files via network or via flash drive, but try not to ever stream a file over a network or flash drive. They can cut out, and if the controller doesn't get the data, it may try to move somewhere that it shouldn't because it didn't get the complete set of data. So always do try to transfer to the hard drive first. Now, in the center of the screen, we have all the different options that your machine will have. And every machine is going to be a little bit different in terms of which options were purchased. But in this case, we've got the home button, which everyone will have, and XY0 and Z0 as well. In this case, we have a W0 because there's a secondary Z head, and an A0 for a fourth axis. There's also a warm-up button, and that's important to do if you have an HSD spindle. Every morning before you run, hit the warm-up button. It's going to move to the center of the table. It's going to spin it up, and typically 2 minutes for half speed, 2 minutes for 3/4 speed, and 1 minute for full speed. So 5 total minutes of warm-up, and that's going to get the bearings nice and warm. They like to run warm. If they're cold, it will reduce the longevity of the spindle. If you are gone for more than an hour or two, you might want to consider warming up again. If it's just a break for lunch, 30 minutes, usually you don't have to warm up again. The tool HT should also be on every machine. And this is a really important thing to do before you set a Z0. So if you have a tool changer, you'll want to get in the habit of grabbing each tool one at a time and immediately doing a tool HT on it after you grab that tool. So to grab a tool, you can type in T1, hit enter. It's going to lift up, run back, exchange the tool. When it's all done, it's going to come forward of the tool changer rack, and then you're going to hit the tool HT button. That's going to go touch off on the white pad at the back of the machine, and you're going to get your tool height with that. It uses that to compare between bits so it knows where your Z0 is set. One of the most common problems that we see in the tech support side is when the customer does the Z0 before they do their tool height. It's then going to be referencing the previous tool height, and your Z0 is going to be in the wrong spot for all additional tools. So whether or not you have a tool changer, you want to do the tool height. If you don't have a tool changer though, every time you replace the bit in the spindle, you'll want to immediately do the tool height. The next button is optional, and you'll see that on machines if the material height touchpad has been purchased. And if that's the case, there'll be a plug up next to the spindle. You'll plug in your material height touchpad, put that on the surface where you want to set your Z0, which could either be the top of the spoil board or the top of the material, and hit the Auto Z button. And what's going to happen is the spindle will lift all the way up and then start coming down slowly. And while it's coming down, you'll want to line up that pad underneath the cutting head, whatever blade that you want to cut with. So whether it's an end mill or a fly cutter, just make sure it's under the cutting surface. It'll touch that twice. The second time will be slower for accuracy, and then it will lift all the way up. At that point, you can remove the material height touchpad, set that aside in a clean, dry place, and proceed with running the machine. Some folks just consider it a quicker way of setting your Z0 rather than having to get up to the machine and real close to make sure your bit's touching the machine, touching the material. The spindle button is just a way to turn on the spindle. So if you have this and you have a tool in there, it's going to spin on. Now in this case, we don't have a tool in there, so it's not turning on. The pins button, pop that up and your pop-up reference pins will come up. In this case, we have a boring head, so a drill down button will also drop the first drill down. So when you're setting your W0 over here with the boring head, you'll press that button first, then bring it down and set your W0 with that. This OSC button, this is oscillation. If you have a tangential knife, you'll have the oscillate button. You may also have a knife down button, which will pop the knife down below the spindle so that you can get low enough to actually cut. There could be some other buttons on here as well. If you have an OptiScout camera, you'll have a few buttons for that. If you have a creasing wheel, you may have some creasing wheel buttons. Laser scanner or laser cutter will also have some other buttons. Right up above that are your jogging controls. So you have fast, medium, and slow. The shortcut keys for that are F4, F3, and F2 on the keyboard. So if you have a wireless keyboard, you can bring that up to the machine and use that as well. So in slow speed, it's going to go much more slowly, in this case 20 inches per minute. Medium, 400, and fast would be 800. Of course, your machine will vary depending upon the model. And below that, we see 1, 0.1, 0.01, and 0.001. So those are increments controlled by the F9 through F6 keys on the keyboard. For instance, if we're in 1,000th of an inch, every time I hit the keyboard, you're going to see the coordinates change by 1,000th of an inch. So you can be very, very precise. If you just want to bump it over just a little bit, you can use those. Typically, you'll end up getting real good at using it in fast speed once you've had a little bit of time to adjust to the controller. Now coming up to the toolbar up on top, the very first button is the start button. That's the green circle. Once you load a file and you're ready to run, you can hit the green circle or the enter key on the keyboard. Both of them will start the file. The second button, we get a lot of questions about this is the restart button. If you want to pick up a file where you left off, either you aborted or the controller aborted for some reason, you can click that button and it will bring up another screen. It's going to show the last 10 jobs that you've run and whether they're finished or unfinished. And in this case, we can click on that one and it's going to say we left off on line 10,975. If we're wanting to start right there, we can hit OK. In this case, we also have wait for user checked. Most of these buttons, these check marks, you're not going to worry about, but this wait for user button right here, that will pause the machine before it actually starts cutting. So that's really useful if you're not quite sure where you want to start off. Like say a bit breaks and you won't even want to back it up a few lines. You can come over here, change that to 10,965 and hit OK. It's going to go over there and pause where it's going to start and wait for you to hit the enter key. Once you hit the enter key, it'll start coming down and it'll start running. The third button on the controller is the single step mode. We don't use this a whole lot, it's more for troubleshooting. If you click that, every G code that runs, it will step through and wait for you to hit enter after each one. The next button is the abort, and the one after that is the pause. These will only show up when a program is actually running. The abort can happen either by clicking that button, hitting the escape key on the keyboard, or by hitting the emergency stop button on the machine itself. All of those will stop the machine. The pause button will stop motion, but it will not stop the spindle from spinning. So that's not considered a safe state. If you just have to pause something quick, you can do that. Just be aware that it is still going to be spinning. The next button is open, and you can get to all of these on the file menu. So we have open, and that will just allow us to bring up a program. So if we go into test files, bring up 2-inch square pocket, now we have the command in the command window right here. We have the name of the file, and we can come over here to the view, and it's going to preview it on screen. So our dotted line is our rapid movement, and green is cutting movements. The button after that is the history button that can also be accessed with a tab key on the keyboard. That brings up all the commands that have been run since the controller was activated this time. And that can be really useful if you're running production and just trying to get through it as fast as possible, especially if you use it with the P positions. So program finishes, you tell it to go to P1 unload, go, change out your material, come back, tab, enter, and it's going to run the same file again. So it's a really quick way of running the same program. The next button is the edit button. That's going to bring up the G code itself. And I don't expect you all to be experts on G code by any means. But a couple things you might notice is the F is the feed rate. So in this case, it's setting a general feed rate for the machine, but then also because this is a Z specific line, it's setting 100 as the feed rate for just the Z axis. So if you wanted to go back and change a feed rate quick, you may not have to go through your camming software. You can just do it quick here. Or if you wanted to change just how deep it was cutting, you could do that right here as well. The next button is simulate. It's going to run through the code, see if it finds any errors. In this case, there's no errors. If someone else gave you the code, if you downloaded it online, you can bring that up and see if there's any errors. And if there are, it's going to tell you what the first error is on what line it's on. It'll also tell you if you're going to exceed any soft limits. And in this case, we're going to exceed the Z soft limits. So if we were to try and run this, it's going to give us an error. So then we know that we may have to adjust it. It's also going to give you a basic estimate of the total time that the machine might take. It does not take into account accelerations, decelerations, tool changes, tool measures, things like that. So it's a very approximate number, but it will at least give you a general starting point. And the next button is the view button. And some machines have a button here, which is a soft limit, which you can turn off if you want to exceed the soft limits. We don't recommend doing that because you could cause damage to the machine if you go too far. So generally, you should just leave those on. At the very top here, we have the file menu, which has all those same buttons. Down here, though, with digitize, if you have a digitizing touch probe, you'll also have the option for automatic or outline. And if you have a laser scanner, you'll have an option for laser as well. Everyone has the option for manual, which is going to bring up another menu bar up here. You can start a file. G0 is a rapid movement. So let's say you had a star shape on the table. You could put a V bit in the spindle, move it to the first point, click G0, move it to the next point, G1, and every point after that would be a G1. And once you're all done, you could close the shape and save it, and you could save it as a DXF file that you could then bring into your CAM program. So even if you don't have a digitizing touch probe, you'd have that option. But with a probe, you could have a 3D scan or an outline scan if someone brought you a part and you just wanted to scan it in. Next menu is the configuration menu. DA calibration, you usually won't have to go in here. This is for configuring the spindle to spin at the correct speed that the controller is giving it on the slide bar. That's all preset from the factory. And same thing with the settings menu. Generally, there isn't anything that has to be configured in here. If you end up upgrading, adding more tool positions, we might go into this box. And tool library, you can put the name of which tool is going where, but generally the controller is going to ignore all these except for a couple of specific situations, except for the tool height. When you do a tool measure, you'll end up getting a value in there for tool height. Now under the view menu, again, most of this can be ignored. The limits will tell you how much cutting area you have on the machine. And the inputs will bring up all the input, the raw input data for the machine. If you were to hit a limit switch, you'd see one of these flash. And that's a good way to diagnose if maybe a limit switch needs repair, has a loose wire or something like that. The toolbars can be made bigger. So if you need glasses, make them a little bit bigger there. Log time totals. All machines for the last couple of years have this log time totals. And it will bring up a box that shows how long the machine's been running, what the cutting time and total run time is. And you can use that especially if you're keeping track of the greasing schedule. Every 40 to 60 hours, we generally recommend greasing. The most important thing is that you have at least a thin film of grease on the rails. If you don't, or if you're doing something like foam that you have to keep wiping off the rails, you may want to increase that greasing schedule. And you can find out where the bearings and how many bearings that you have are if you look in your owner's manual. The refresh and clear do exactly what they say. So you hit clear, it just clears everything on screen. Under the options menu, generally you're going to want these to be checked. If your keyboard suddenly stops working one day, make sure keyboard's checked. Auto repeat. A lot of folks like that because as soon as it's done running the program, it's going to pop the name back up in here, and all you have to do is hit the enter key. Now, the downside to doing that is that if the keyboard gets bumped while you're up changing material, it could start running the machine, so you'll want to judge and just make sure that the machine is safe before you approach it. Auto run is for a feature that's not used too much, but there is a way to set up WinCNC where if you just drag a file into a folder, it will automatically run. So that's not used a whole lot. And auto preview means that as soon as you open up a file, it's going to preview it on screen, and you don't have to hit this little eyeball button. Now, if you do have that on, just remember that it's going to try and preview every program, including the macros like tool measure and home and pins. So you may end up having to hit those buttons twice because it'll preview those the first time. Under the units, you can change the machine into inches, centimeters, and millimeters. Generally speaking, you're going to keep it in inches. You can draw in another unit, like say millimeters. Someone gives you a millimeter part, draw it in millimeters, output it with an inch post-processor and run it on the machine in inches. That way you don't have to worry about is the machine in the right units or not and changing back and forth. It just keeps things a little bit easier. Transit and jog are what we talked about before with these buttons right here, these fast, medium, and slow, and the increment buttons. And under the help menu, there's two things you might want to look at. First is about. That's going to tell you what software version you're running and what your serial number is and what options you have enabled for your machine. And also under the help topics, it's going to bring up the WinCNC manual with everything about how the controller functions. For the most part, you won't need to know most of this, but it does have all the G codes, M codes, and L codes that the machine can understand, as well as a couple pages that show all of the shortcut keys for operating the controller. So that's all available through that menu. And now let's go back inside and discuss drawing in VCarve. So now that we're back in VCarve, we're going to go through setting up a file and doing some basic drawing with included drawing tools. So the first thing we're going to do is click Create a New File. When we do this, the first thing that shows up is the job setup screen. In version 10.5 of VCarve, we have three options. We have single-sided, double-sided, and rotary. Primarily, we focus on single-sided. Double-sided lets you do a flip part, and of course, rotary is a fourth axis. So let's choose single-sided, and we're going to give a job size setup. And this is going to be whatever size sheet you're working on at the moment. So if you have a normal 4x8 sheet, it's usually something like 49 by 97. And the thickness is just whatever thickness of material you're working on, in this case 0.75 inches. And you can choose inches or millimeters. And the Z0 position is really critical to match both on VCarve and on the router screen. So the material surface or the material bed is either top of the material or the top of the spoil board. And that's going to come into to be really important later on once we actually get out to cutting. So for now, we're going to choose material surface. And your XY0 position is almost always going to be at the bottom left of the screen of the material, and that has to match on the machine as well. Generally, don't want to use an offset unless you're doing it at the center of the part for some reason, but we can get into that later. So right now, just the XY0 position is lower left. And modeling resolution, you can usually leave it as standard to start with. You can always increase it later. There's also some other options in the toolpath to get even more accuracy if you need to see some really precise details. So in this case, we're going to go standard, and the appearance is just for taking screenshots to send it out to customers. So we're just going to leave it on cherry right now. So we click OK, and on the left side are all of our drawing tools. So the main things we're going to be going through right now are how to create vectors under this Create Vectors tab. So we have Draw Circle, we have ellipse, rectangles, polygons, and stars. We have polylines, arcs, Bezier curves, and a few other things we'll get into in a minute. So first we're going to draw a circle. And to do this, you can either come over to the screen, click and drag, and you can see it reads out what the diameter is and just allows you to make the circle wherever you want and however big you want. But you can also be accurate if you know exactly where you want it to go. For instance, maybe I want to start at 0, 0 and have a diameter of 6 inches. Now you can see the last one I drew, since I haven't modified it yet, got moved down here. And it just applied the change directly to that circle. So as long as you haven't modified it, you can actually change it, scale it, move it, rotate it through this box. So now we have our circle here, and we can zoom in using the mouse wheel. And when you're zooming in, it's important to zoom in towards the part. So you put your mouse right in the center of the part where you want to zoom in, and just zoom right in with the mouse wheel forward. When you're zooming out, you typically want to move your mouse away and zoom out. That way you'll be able to see the whole thing. If you zoom in like this and then zoom out right here, it's going to try and focus around the mouse, and you may not see the whole part. Ellipses work very similarly, except that you're going to have an anchor point. So in this case, I'm going to start my anchor point down there, and I'm going to go ahead and draw, and you're going to give it a width and a height and apply it, and you'll get, just like the circle, an ellipse drawn on screen. Now, rectangles are very similar as well. You're going to have an anchor point, a starting point, a corner type. So I can have a square corner, radius internal or radius external corners as well. And you can choose the size of that. Now, for external radiused corners, those are what you might commonly call a fillet. And there's another tool to change that to be radiused later on. The internal radius don't have a specific tool for it, but if you haven't changed the rectangle or haven't modified it in any way, you can come back into this tool and apply it later. And of course, you can set the size and shape of it. You also have a polygon, so you can come out here and draw different number of sides, pentagons, hexagons, etc. The center point, the radius, side length, it's all there, as well as star shapes. And again, you can give it how many sides, how many points you want it to have. Now, to select all these, we can draw a selection box from left to right, and anything that's inside that selection box will be selected. You can see it all goes with a dotted pink line. If I click off of it, it gets deselected. But in VCarve, there's also another way to select things, which is if you click to the right and drag to the left, anything that's touching will be selected. You don't have to surround the entire shape. So right now, these three shapes will all be selected even though I didn't surround them. And that's a really handy tool, but it's also important to know it's there so you don't select things you didn't mean to select. So if I go into the polyline tool, this is one of the most commonly used tools. And there's several ways to use this tool. Just like every other shape, you can click, 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 and it will just draw a point wherever you click. When you get near the final, the start point, it's going to automatically snap to that start point. So it'll complete the shape and call it a closed contour. But we can also just tell it exactly where we want it to go. So if I wanted to draw a rectangle, I could easily do that here. I can click X0, Y0, enter, and it draws a line. Now if I move my mouse over, I've got my start point right there. So now I can draw 10 and 5, and it's going to draw a diagonal. I can bring this back to 0 and 5, and now I can bring it back to 0 and 0, and it's going to complete the shape. You saw it change color, and now I have a triangle. I can do the same thing with a star shape as well. To get out of a tool, you just right click. So if I'm in a tool here and I'm drawing, I can right click, and it'll stop the tool right there and give me this particular shape. But I can also change, I can give it a start point and change the angle or length as well. So if I knew I had a shape that had to have a diagonal that's exactly at 30 degrees and it's 5 feet long, or let's say 60 inches, it's going to give me that diagonal at that angle. I don't have to try and figure out and do the math where this endpoint is. And now I could either do up or down from there using dx or dy, or give it specific XY coordinate points. But if I knew I wanted to go from there 5 inches up, I can say X0, Y5, and it's going to go straight up. And then I can switch back to using my coordinate points if I know I want that to go to X0 and Y20. And then again, I can go back to X0, Y0, completes the shape, and now I have my finished shape. Again, now I can click that. I can use the delete key on the keyboard to get rid of a shape. Click that, or I can right click and I can click delete, and that gets rid of it as well. Now, one of your biggest friends with VCarve is going to be Control Z. That's going to undo the last operation. So in this case, it brought that back, and it keeps several of them stacked up. So I can do a Control Z, Control Z, Control Z, and it can keep going backwards if I want. Again, I can select right to left and delete, and delete. Another tool that's used a lot is the Draw Arc tool, and this is used a lot, especially if you're tracing parts. And there's two different options here. One is through 3 points, so you can click to start, click to end, and then drag out the radius. Or you can do a center start end where you click 1 point, click another point, and then you have your part of your circle that you want to draw. Now, of course, you can set all these if you know the exact coordinates you want to go through as well. VCarve does have a vectorizing tool, a tracing tool, and that's right here under Trace Bitmap. But sometimes, as we'll see later, it may not vectorize perfectly. And this is where we may use this Draw Arc to go in there and actually draw something specific to match a little bit closer to the part we're trying to trace. We also have Draw Curve, and this is going to be our Bezier curves. So every time we click, we get a handle there, and it creates a curve going around those points. Now, if we right-click to get out of the tool, right-click again, we can go into Node Edit mode, and we're going to have all these different handles that we can drag around. And this lets you get really detailed on making some interesting shapes that you couldn't otherwise make. And while we're still in Node Edit mode, we can right-click and we can insert a midpoint or another point, or we can change a line to an actual line or an arc rather than just a Bezier curve. And this works for all the different shapes as well, whatever tool you're in. We could also cut the vector. So if we wanted to take a piece out of this, we can right-click twice to get out of the tool. And now when we select it, we see that just that little section turns pink. So I delete this, and now I have an open contour. Let's get rid of that. The next tool is a vector texture tool, which we'll use here in just a minute when we start building things. We also have a Draw Text tool, where I can just type in whatever I want to say. I can choose my font. And these are going to be all the fonts that are in your Windows Fonts folder. So if you want to add more, just find the Windows Fonts folder on your hard drive, drop them in there. Next time you open up VCarve, they'll show up. And I would recommend using a true type font. And that's what you're going to see right here with these little TTs. Right here we have the letter O. This means it's an open type font, and they may or may not show up properly. So ideally, always try and find a true type font if you're adding new ones. And you can also give it the text height. Now the text height is, when someone's making a font, the total blank area that they have to draw with. So for instance, 8 inches for text height is going to be maybe where this H or where these L's are, but the E isn't going to be 8 inches tall. That's the blank area that it has to work with for a particular character. So keep that in mind as well. And of course, your anchor point, you can tell it that you want it to be in a specific location as well. Anytime, if you're out of this tool and you want to come back into it, until we change it to curves, you can just come back up here to the Draw Text tool, and it's going to put the text back in this box, and you can change it however you want. There's a couple more text tools, which again, we'll get into in a little bit here once we start drawing. There's also text on a curve, and it doesn't necessarily have to be an arc. So let's bring this back out here and say I wanted to put my name on there. I can choose text on a curve and select both of these. And in this case, it's a little bit too long, so we can shrink it down. We can try and scale that text down, and as soon as we do that, it shows up on this curve. And now we have the options to move it out onto or on the other side of the curve. We can flip the text around. We can change it to be left aligned, middle, right aligned, or aligned to curve, or keep them vertical, which will then align them with the vertical axis here, but still follow that curve. And if I go back, of course, it gives me that error. So then it automatically flips back to scale text to fit the curve. And it doesn't just have to be this arc. I can have any kind of crazy winding shape that I want, or a rectangle box. It will make it follow that shape. All right, now let's go ahead and actually draw something. So we're gonna go into, first draw a rectangle. Let's say we wanna make a plaque with our name on it. We choose rectangle, and we're gonna start with an anchor point at the lower left corner at 0, 0. It's the best practice to always start at this lower left corner. If you have a particular shaped remnant and you want to put it in a specific location on there, that's maybe when you would change it. But for now, we're just going to start at 0, 0. And I want these internal radius corners so it looks like a really sharp plaque, really nice looking plaque. And for size, let's say we're going to make this 15 inches by 10 inches. So we're going to put in 15 by 10. We're going to say create, and it puts our plaque down there. And that looks pretty nice. Now let's say I want to put a recessed area in the middle that I have to pocket out. I'm going to put my name at the bottom of it, and I want some kind of texture to it, and maybe I want some chamfered edges. There's a couple of different ways I could do that. One, I could go back in here and I could draw another rectangle with a slightly different size radius corners and a slightly different size and slightly different anchor point, but that would be a little bit more complicated. And like anything you do in VCarve, you're going to find that this would have multiple different options. I could also do a copy and paste. So if I do a Control-C on the keyboard and a Control-V, you see now these lines got darker. That's because it pasted a second object right here. So I could go into the Scale tool, set selected size, anchor point of center so that it collapses around it, and I could change this size to be slightly less, say 14.5. But as you notice, it scales both the width and the height together. So instead, what I'd really want would be to uncheck Link XY. And now when I change one of them, it's not going to change the other one. So in this case, I can make it 14 by 9, hit apply, makes this smaller, and I could realign it with the center right here. But as you can see, this isn't quite right. Maybe that's the look I'm going for, but in this case, I want something that changes that curve as well. So the easiest tool in this case is going to be your offset tool, way down here at the bottom left. And I'm going to offset inwards. I have the option to go outwards or both. And I want to inset by 1/2 inch. And I don't want to delete the original because I want to keep that as my outside border. There we go. So now that's my inside that I'm going to pocket out of. Right in the center, of course, I want to put the name there. Now, one way of doing it, again, there's always multiple ways, is I can come in here and I can change the text size, get it to fit, I can drag it into the center. And VCarve, if you have these snapping tools on up here, will tend to allow you to snap to things. So in this case, centering to my snapping tool, or to the center of the box right there, brings it right there. But you can also see that the G is off a little bit, so I may want to bump it down. And I can use the arrow keys just to bump it down a little bit. In VCarve, the closer you zoom in, the less that bump is going to affect it. When I zoom way out, it's going to create much bigger jumps. If I hold the Control or the Shift key, you can see those jumps change size significantly. And those are always going to be the same size regardless of the zoom level, unlike the regular bumps. But there's another way to do this as well, and it's right here under Transform Objects. We can go to Align Selected Objects. And you have all the different tools. I can align to a specific shape or to the center of the sheet. And all the way down here on the bottom, it says Show Common Tools on the Drawing tab. Now when I click on that, that brings out all those tools right down here, so it's easier to use. So now I can just come out here, I can select the two shapes that I want, and I can click Align. And you see, because of the order I selected these, it moved the name right to the center. If I had selected in the opposite order, it would move the box to the name. So now that that's done, I want to put some kind of fancy texture in here. And that's where I'm going to use this texture toolpath, vector texture. So I'm going to click the inside inside rectangle. And I'm going to choose my angle, my spacing, which can have some variation to it, wave parameters, how much variation there is with the noise, and hit preview. And it's going to keep these lines inside. So you'll be able to see they go right up to the edge, but they go on top of the name because I didn't select the name. In this case, if I'm doing something like V-carving the name down into the plaque, that's probably how I want it. I want the bit to spend the most time cutting the material. It's going to save me time overall. And then I'll carve this out after that. However, if I wanted to keep it in between the name and the rectangle, I can select both of them. I can do this and hit preview, and it's going to keep that texture outside of the name. Now in this case, I really just want it to be around there. So I'm going to click OK, and it's going to fill that in. And perhaps I want a couple of drill holes as well. I'm going to choose draw a circle and choose a 1/4 inch diameter or whatever size drill hole I want in order to hang the plaque. And I'm going to choose where I want those to be. So I could go out there and just click a spot, or I could click, say, 2 and 9. And now I have my 1 drill hole. Now, since this is a relatively easy shape, I could just go do the math and say, well, we're 15 minus 2 would be 13. And we have another circle right there. But if it was a more complicated shape or I didn't necessarily have the coordinates down, there's another way to do it as well, which is mirroring. So one way I can do it is I can draw a line straight down the center of my part. I can take those 2 pieces, come into the mirror tool under Transform Objects, make sure that Create a Mirrored Copy is checked, so there's a second one, it doesn't just move it. And then I can click Flip Right, and now we see we have a second copy right over there that's exactly mirrored from this one. That can come in really handy when you start doing more complex shapes. And then I can just select the line and delete it, and we're good to go. Now I'm going to start putting toolpaths on here, because of course I want to actually cut this. So we're going to come all the way over to the right side and get our toolpath menu. And I like to hit this little auto hide button, this little pin icon. It keeps it out so it doesn't keep moving around on me. So now I want to think about the order that I want to cut this. Of course, the very last thing I want to do is cut the shape out. But in between there, I want to create that pocket. I want to cut the name out, put this texture on, and then also drill those holes. So the first thing I'm going to want to do is cut that pocket down in there. I'm going to come over here to the second option, which is Pocket Toolpath. And in this case, my start depth is going to be 0. And normally, for most of your toolpaths, it will be 0. And my cut depth is how deep I want it to go. So in this case, a 1/4 inch. And I'm going to choose my tool. These will all be selected when you first set up VCarve. You're going to come in here and in your tool database, set up all your tools. In this case, we have a number of them already set up. So I'm going to choose my tool, and all these parameters should be set up. But if I wanted to change them only for this toolpath, I can click the Edit button and fill in all this data here. So say I wanted to do, instead of 200 inches a minute, I only wanted to do 150 inches a minute for this particular run. I could do that, and it won't change what's in my tool database. Then I'm going to choose which type of pocket I'm going to do, either offset or raster. Offset's more like a spiral where it will start on the inside and work its way outside, whereas raster is going to go back and forth, and generally you're going to choose the longest direction when you're doing that. So in this case, I'm going to choose 0 degrees, which is left to right, whereas 90 would be lengthwise down the machine. And I'm also going to do a last profile pass, and this is going to come around the outside and do a cleanup when it's all done. Now the next option is ramp all your plunge moves. And this you're going to do on any down cuts or compression bits. And it's absolutely critical that those bits are ramped in, not plunged, because they will burn the material. They have the potential to start a fire, or at the very least burn out the bit early from the excess heat. And I tend to ramp in at least twice the distance that I'm ramping down. So in this case, I'm ramping down a 1/4 inch. I'd want to do at least a 1/2 inch. I'm going to choose 1 inch because we've got plenty of space here, so it's not going to hurt anything. We're going to click Calculate, figures out our toolpath. We can see, I can click the middle mouse button, the mouse wheel, hold that down and move it around. We can see it's just going to raster back and forth, and that's going to be my first option. Now back in the 2D view, I'm going to turn off that toolpath so I can see everything clearly again. And the next thing I wanted to do is do these texture lines. I'm going to come back up here to Profile, and I'm going to configure this. This would be one of the few cases where you do have a start depth, because we already pocketed out this area. So we want to start a 1/4 inch down, the same depth we pocketed out. But our cut depth then is going to go down from there. This is not a total depth down. This is only the amount you're going down below the start depth. So in this case, I only want to go down a small amount, like 40,000ths of an inch. I'm going to choose my tool, same as before. In this case, I'm going to choose the V-bit. And one pass, because it's not going very deep. And I'm also going to choose on the line. Outside and inside will offset the bit left or right. In this case, I want it to actually follow directly on this path. And for this particular toolpath, we don't have to worry about any of these other options, and we'll come back to those later. So now we have that toolpath, and we can go back up to 2D view, deselect our toolpath, and now we can cut our name, come back to close. And in this case, we're going to do a V carving. Now, a V-bit can be used in two different ways. You can do a profile just like what we did there, or you can do a V carving. And the V carving is going to make the lines of any shape, any closed shape, come to a V groove, a V shape. So if you have a 90-degree V-bit and you have a box that's separated by, say, 6 inches, it's going to try and make that a 3-inch deep cut to try and make those two lines hit a V. So in this case, we want that. We want these two edges to always come down to a V. And our start depth is going to be 1/4 inch. Our flat depth, we can choose if we only want it to go down a certain depth. So if we don't fully want it to hit that V, or we don't have a thick enough material, it can come down to some flat bottom and then just carve that out. And if we have a rather large flat bottom, we can choose a clearance tool, say some sort of an end mill, 1/8 inch end mill, 1/4 inch end mill, add that to here, and that will take care of the majority of the clearance area so that we don't spend a lot of time with our very fine V point trying to clear out that area. Now in this case, we're not going to do that. We're going to hit calculate, and it's going to create some really nice sharp lines in these corners. So again, we've got 3 more toolpaths to do. We're going to come back up to these drill points. There's another option for drilling toolpath. Again, start depth 0.25. In this case, our cut depth, we want to go all the way through material. We should have 0.5 left. Because we're going all the way through, we have to be knowledgeable about what kind of bit we're using. So if we're using a drill bit, you usually have to go a fair bit deeper than the material is thick in order to make sure that that drill point actually gets all the way through and creates a full-sized hole. In this case, we would have 1/2 inch left, so we may end up going to, say, 0.625, but that's going to depend on which drill bit you're using. And again, I'm going to come in here, choose my tool. In this case, I already had it selected, 1/4 inch drill bit. Peck drilling is going to bring the bit in and out of that hole, and each time it's going to go a little bit deeper, and that's used if you're having to clear the material out of a rather deep hole. In this case, these aren't all that deep, so we're not going to do that. And dwell at the bottom of the pass will allow the drill to sit and spin at the very bottom, just to make sure that it's all the way through in clearing the hole. We hit calculate. Now in this case, it's telling us that we're going to go all the way through, which is fine. The next thing I want to do is put a chamfer toolpath around the outside. But there's a couple different options. With version 10.5, they actually have a chamfer toolpath specifically. But because we have a big enough V-bit here, we don't have to use that. We can actually just plunge that V-bit and run it around the perimeter. So we can come in here and profile. And in this case, our start depth is 0. We're going to start at the very top. And we're only going to go down about 1/4 inch. And again, we're going to choose our tool. And we're going to check on the line. In this case, it was already set up. It remembers the last settings that we used. And now we just get a profile line right around there. Come back and do one more, and this time we're actually going to cut it out. So we still have our outside selected. We're going to choose Profile Toolpath, only this time we're going to be cutting all the way through. And if you have vacuum hold down, you may be able to get a very accurate number here. If your material is 0.75, you may be able to go 0.75 or 0.76 or somewhere in between. If you don't have vacuum hold down, if you're just using clamps, a lot of times the material will have a bow to it. So you may end up going with something like 0.77, 0.78. It's going to depend on your material, of course. And for the tool, in this case, we're going to choose our compression bit. We're going to choose outside so that it actually offsets that tool. We're going to ramp it in. And in this case, we're going to go at least 1.5 inches In this case, we got plenty of space, so 2 inches is fine. We're going to calculate, and again, we're cutting all the way through. And now we can preview it. There's a few different preview options. We have preview selected. Selected is whatever one is highlighted in blue. Preview all toolpaths, that's whatever's in this list. Preview visible is whatever's checkmarked. And of course, reset, if we previewed it once and we want to go back to clearing it all out to make a change, we can do that. In this case, I'm going to preview all. And once it's previewed, we can double click on the material, anything that's left over, and it'll get rid of it. And again, down here, same thing. And so now here's our finished plaque. And we can left click and tilt it, and we can see it at an angle. And you can see in here, this is because we didn't use a clearance tool, so we're trying to clear out this area with our little V-bit. So if we have an 1/8 inch bit or a 1/16 inch bit, we may come back and clear that up. That'll probably save us some time as well. But we can also see that around the outside here, our V-bit's cutting in to the edge of our border. And we don't really want that, or at least I don't in this case. So what I'm going to do is come back here, and I actually have to offset this. I could do a scale object size, just like we did before, or I could offset this border again and do another toolpath on there. In this case, I'm just simply going to offset this. So I'm going to change set selected size, again, uncheck linked XY, and I'm going to move it in a little bit depending upon the size of your bit. If you have a 1/4 inch bit, you may not have to move it as far. So let's say in this case, I do 13.5 and 8.5. And we want to make sure that we're on the center so that the whole vector texture stays centered. And you can see it offset it from the side. We can come back here and we can right click and choose recalculate all. Goes through, yep, we're cutting all the way through. All toolpaths successfully recalculated. Come back to the 3D view, reset the preview, preview all toolpaths again, and we'll see if that got it away far enough. And that looks pretty good. There is a little bit left here, so we may decide to come back and tinker with this just a little more, bring this in maybe another 1/8 of an inch on each side. Overall, that's looking pretty good. So in order to get this out to the machine, we're going to come back over here, we're going to close, and we're going to click the Save Toolpath. Now in this case, it will depend on what type of machine you have, what options you have with your machine, to exactly how you're going to proceed here. If you want to put all visible toolpaths to a single file, you'll want to have either a tool changer, automatic tool changer machine, or have all of those toolpaths be the same tool. In this case, we have different tools, but we also have a tool changer. So we can just select all of the tools. And what it's telling us is that both of these toolpaths are using the same number tool, but the actual tool is different. So what we can do is come back to Profile or Drill, Edit, and change this tool number. Now, of course, once you set this all up for what's on your machine, they should all be in the correct order and you won't get that error. But now that we fixed that, we don't have any more errors here. And we just have to remember now to move our drill to that, the tool that we just changed it to. We can click Save, and we can come in here to today's date. And we can click, we can type out what we want it to be, Logan plaque. And now we have our toolpath. We can come back to the controller screen and we can open it up and click preview, and it's going to show up on screen. And now we could get an estimated time of how long we expect it to take. In this case, about 13 minutes. Now keep in mind this does not include accelerations or decelerations, so if we're doing a lot of little details, it's probably going to be a little bit longer than this. But that gives us a good estimate for what it's going to be. If we don't have a toolpath, we're going to save these separately and run them successively one file after the next. So we can click a single one, and we're going to choose our different post-processor. So instead of ATC speed, we're going to choose our M5 speed. We're going to click Save, and we can give it the name. Now in this case, I would call it Logan Plaque 1 and 0.25 NMIL. And what this is going to do is keep it in order when I look at it in the file folder. We're going to have toolpaths 1, 2, 3, 4, 5, etc. And we're going to see which tool it is. So if I come back to this 6 months from now, it'll actually tell me which tool it is. But VCarve 10.5 has another function where you can say visible toolpaths to multiple file and group where possible. So because these two toolpaths right here are both using a VBit, it will automatically put those two together. So if I select all the toolpaths and I say Save Toolpath and click Save, now in this folder we have exactly what we're going to do individually. So Logan plaque 1, 2, 3, 4, 5, and 6, and it combined 2 and 3 into 1. The only thing is it doesn't put what the tool is, but you can also change the name right here. We can say rename to 0.25 end mill, and now when we save it, it will give it that name instead. now that we've made a plaque, let's see if we can nest that out if we want to make multiple plaques. So we're going to go back to the 2D view, and there's several ways that we could put this across the whole sheet. So one way, we can just select all of the lines that we have drawn, deselect our toolpath so we can see it, and we can do an array copy. And what that's going to do is give us a certain number of rows and columns of whatever we've selected. So in this case, let's say we want to make 3 rows and 3 columns. We just want 9 of these. And we have to choose, do we want it offset or gap? So a gap would be how much space is left between the two plaques, and an offset would be from, say, left edge to left edge. So we're going to go a gap. And generally, the gap between parts you want to be more than twice the diameter of your tool. The reason being that you want your tool to be able to grip on the material on both sides so you don't get excessive vibration. So if we're using a 1/4 inch tool, we would want something more than a 1/2 inch wide. So in this case, let's say it's 0.51 and 0.51. And all we have to do is say copy. And in this case, the computer is going to go through, and that happened pretty quickly. It replicates all of the lines that we drew out here. And what we could do then is go through these tool paths, say double click and mill. And now we can go through and choose this one. We can go through and choose all of our inside rectangles here, 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 and here. And just come back down here to calculate, and it's going to fill that in across the entire sheet. We can reset the preview, and they're all right here. And we could go through and do that with all of these different options. So that's one way of nesting, just creating a simple array of parts that fit on the sheet. However, that is a lot of work to have to go back through and grab each individual vector and re-toolpath it. So there's an easier way to do it. What we can do is come back in here. In fact, let's delete all these parts. Computer's just thinking on it here. There we go. We'll grab all these toolpaths again. And we're going to come back up here to, first of all, change this to be only this one rectangle since we got rid of the other ones. And there's an option for array copy toolpath. So all of the toolpaths that are selected are going to be arrayed out just like we did with array copy vectors, except that it's only putting out the toolpaths rather than the entire vector set. It makes it faster. You saw the computer calculate a little bit faster, and I don't have to go through and select every one over and over and over. It makes it a lot easier. And of course, we can preview all of these, and we'll get our whole sheet there. And the speed that this goes at will depend on 2 factors. One, this speed slider bar right here. If we bring it all the way to the left, it's going to go at real-time speed. So you're going to see it slowly move back and forth if you wanted to watch that and just make sure it's going the right speed. But we can also speed it up, and the maximum speed will be dependent on the computer processor that you're running this on. The faster your computer processor is, the faster this is going to preview. The one other factor that can come into play is the preview simulation quality, and in this case I have it set on maximum, so this is going as slow as it possibly can. We can bring that back down to standard and preview all, and it goes much faster, as you can see. And we would only do that if we don't necessarily care about seeing all the detail. As you can notice here, it's much more fuzzy because it's not trying to render all that little detail. So now that we know the one works, we can do that and speed everything up quite a bit faster. So that's one way of nesting all the parts. However, some parts aren't necessarily as simple as a rectangle. And there's another option here for nesting. And what this is going to try and do is rotate all the parts to fit them onto your sheet. And you can give it a different rotation step angle and the gaps in between the material and how many copies you want, and it will try to put all those onto the single sheet. Now in this case, nesting won't do much because it's just a simple rectangle. So before we move on, let's save this. So we already saved the toolpaths. We're going to come back up to File, Save As, and we're going to give it the name Logan Plaque. And this is actually saving the VCarve file. If we wanted to come back and make any changes to this later, we would have to have this file because the G-code file can only be read by the machine. However, when all these other ones pop up that we've already named, we want to avoid clicking on these. And this is really important. If we don't click on anything, it just says Logan Black, we click Save, and it's going to automatically put the CRV extension on there. If we were to click on one of these, it's going to give it the .tap extension, and it's going to put our drawing file on top of our tap file. Now the machine will no longer read it, but VCarve won't read it because it's not a CRV file. Now we could rename the tap to CRV and get back to where we started, but if we went the other way, if we put our toolpath on top of our CRV file, then we've lost our drawing altogether. So we want to avoid typing anything else in here or clicking on any of these. Just type the name we want, click Save, and now we have two different files in that folder. So let's start a new file with, and just make an interesting little shape, something that's going to nest a little bit easier. So I'm just going to draw a little circle there and maybe a couple little points, and let's even say just a rectangle, just something that's going to give us an interesting shape. We can use this trim tool, as you saw me grab right here, and it takes away any extra pieces that are intersecting. So when I grab trim, come back up here, click the part, and in version 10, you can actually just click and drag, and anything you touch will go away. Again, Control Z is your friend. So undo that, and there we go. Now, this is all one part. Of course, we didn't do this little part here, so let's click that. And right here, there's an option for rejoin trimmed sections. So when I click this, it puts all of this together in a single shape. When I click on any part of it, the entire thing is selected. If I didn't have that check marked, I would get individual pieces that I would then have to check and join together. So let's say I did that. Let's say I uncheck this. Now I've got two separate pieces here. How do I get them together? Well, there's a tool called Join right here under Transform Objects. So I can select everything, Join, and in this case, I'm seeing two open vectors, so two non-closed shapes. And when it's all done, it's going to create a closed shape. Now in this case, because they're touching, we can keep this tolerance very low. If we have to increase that tolerance in order to get this shape to be closed, we can do that. But do keep in mind that the higher that goes, the larger of a shape that it will encompass. And if you have two lines that aren't necessarily actually touching, it will snap those two lines together to make them work. So we're going to click Join, and now we have our single shape. Now we can proceed to nest that. So let's say we have a simple toolpath on here. We're just cutting all the way through this one part on the outside, just like that. All right, now we want to nest this part. We come into nesting. We tell it how far apart we want these parts to be, and the rotation step angle. There's no perfect rotation step angle. I've had times where 45 degrees works great. I've had times when 2 degrees works great. Sometimes 3 degrees works great. So what I tend to do is start at 45 degrees, and depending upon the results we see here in a second, I will slowly step it down until I find the one that fits the most parts on the sheet. I'm going to choose some number that I think might fit. Let's just say 150 copies. And now it puts a little 150 there, and when I hit preview, it's going to fit them all into a sheet if it can. In this case, it can't. We have an extra sheet. If this was the exact number I wanted exactly 150, I can double click on sheet 2, I can put my toolpaths on here, and then I'm good to go. However, if I didn't want that many, I just wanted as many as I could fit on a sheet, what I can do is try to get this number a little bit closer. So I can reset, change this down to say 125, hit apply. Those all fit on one sheet, but I might be able to fit a few more. So let's say 135, preview. And now this gives me 3 extra here. So now I can try changing my rotation step angle. Let's go down to say 22 degrees, reset, preview, but 22 actually got worse. There's more parts left over. So let's say I go down to 10 degrees, preview, and it's somewhere in between. And let's try 3. And now 4, we're close. I can go back down to 2 and preview, and that went back up to 5. So there's no perfect number to start with. In this case, 45 got us the best. We only have 3 left over. So I can come back in here, change this down to 132, preview. Yes, I want to apply that. And now I've got 1 full sheet of nested parts. Now in this case, this is a relatively simple shape. So I could simply go into my toolpath, do a Control A. Control A is select all. There we go. Now I've selected everything and I can hit calculate. We're cutting all the way through. Now we have a nested sheet and I can preview it and get rid of the extra, and there's all my parts. Let's say I wanted to send this to a customer. There's a save preview image right here. If I click that, it gives me an option to save it as a JPEG or a bitmap or PNG. So I can choose one and give it a name, and now I could send that file to a customer so they could approve it. And I can also change what color the material is or what grain it has, whether it's metal or plastic or wood. That's all in that option right there. Let's say if we had a more complicated part, something where maybe we couldn't just grab it all at once. So let's put a few different options in here. Let's say we have some kind of shape there and we have some other shape over here. And we have different tool paths for each of those shapes. So we're going to grab, say, a pocket tool path, and we're going to go down 1/4 inch in there. And we're going to come back here. And let's say we're going to do a V-carving in this. We're going to reset the preview, preview all. And in this case, we didn't recalculate our first tool path. So we're going to recalculate all. And one more error has occurred. And what that means is that we didn't select this option after we undid everything. So we're going to come back here, select this, calculate. And now we can preview all. And we're back to our single shape. All right, so now if we wanted to nest this, we could certainly do it the same way. We already figured out those parameters. We're going to grab all of these. And this would be one of the few cases we're going to group something. We're going to group it all. And that's going to keep all of the pieces together when it lays it out on the sheet, rather than trying to fit these individual parts inside of each other. So we're going to nest it. We already have our number from before. Apply, preview, and they all fit on the sheet. But if I wanted to toolpath these, I would have to go through and select all of just this one. And that's not going to work out very well. So there is an easier way. First, though, I'm going to ungroup these, because if you notice, when I come in here, none of these are selected. That's because they're grouped, so they're not considered to be on any particular layer. So I can select everything, ungroup, and what I'm going to do now is actually undo everything before I nest it. And again, Control-Z is undo. And I'm going to change the layers that these are on. So I'm going to do move to layer, new layer, and I'm just going to call this the border layer. Okay, and I'm going to choose this and say move to layer, new layer. I'm going to call this the VCarve layer. And up at the top here is your layer toolbar. So we're going to turn off the other layers. We can turn on one or both, and this lets us toggle between them. Whichever one is selected in bold, that's the one we're actually drawing on. So if I were to draw something new, that's the layer it would be on. Now, when we do our toolpaths, we can choose Profile 3. We come all the way down here to Selector, and we're going to choose everything on the border layer. Calculate that. Pocket 1. Choose our selector. That's going to be everything that's on layer 1. And VCarve, that's going to be everything on the VCarve layer. Now for just one part, that was maybe a lot of extra steps. But when we go through nesting this, again, group it. And when you group it, it pulls everything back onto the first layer. We're going to nest it, 132, preview, okay. And now we're going to select everything, again, Control A, and we're going to ungroup everything. Now we can recalculate all the toolpaths. And it's going to give us a toolpath for all of these. Now it gave us an error, so we just have to go through and figure out what that error is. In this case, we should be choosing everything on the border layer, so that's all of those items. Calculate, we're going all the way through. We're going to click Pocket. We're going to select everything on layer 1, which now those are all highlighted. Calculate that. And VCarve, select everything on the VCarve layer, calculate it, and it lays everything out. So in this case, it really just needed to be reselected. We can go back into the preview, reset, preview all, and now it lays them all out on the sheet, and I didn't have to go through and select all of those individually, and it saved me a ton of time. Of course, now when I'm ready to save it, I just come back over here to Save Toolpath and output it just like we did before. There's also an option right here for a summary of all toolpaths. And what this is telling me is that at these particular speeds, it's going to take 1 hour, 12 minutes and 33 seconds to complete this. Now again, that does not take into account accelerations or decelerations, or tool changes. So what VCarve has done is put a scale factor in here. And this is something that you'll have to play around with on your machine to figure out exactly what that scale factor should be. Generally, somewhere between a scale factor of 2 and 2.5 seems to work pretty well. If you're doing a lot of 3D carving, something where it's going to be doing a lot of acceleration back and forth, never at full speed, that number might be higher. Whereas if you're doing just one long straight cut, it's going to be a lot lower. All right, now let's go ahead and see about how to import files. So the first thing we're going to do is import a file. And to do that, we're going to go up to the File menu, and we're going to click Import. And we have several options here. The first option is Import Vectors. So if we're going to bring in a drawing that someone else has already made, or we've made previously, typically a DXF file or a DWG file. So for instance, say this flange DXF, we're going to open that. And that's going to come in as vectors. So they're already selected, they're dotted pink lines, and now we can immediately put a toolpath on them. They are ready to go, assuming that they're closed shape. So like we talked about before, we go over to Join. And in this case, we have 12 closed shapes. So we know we don't have to do anything more with them. If they were open, we'd have to join them. And it's possible, depending upon what program they were made on and who made them, we may end up having to join those shapes or do some extra work to get them to come together. But in this case, they're all good. And we can just go forward and put toolpaths on them just like we did before. So let's go ahead and delete that. The next option is to import a bitmap. And it's not just bitmaps, BMPs. You can also bring in JPEGs, GIFs, TIFFs, PNG files, almost any image file. And you can see there's plenty of them that we've called up here. So we can say bring in this blade file, and it appears somewhere on the sheet. In this case, it's black and white, and ideally that's what you want. Black and white will give you the most contrast. It'll be the easiest for VCarve to try and vectorize. So we can come back to what we saw way in the beginning, which is trace bitmap. And we're going to choose black and white. Even if the image isn't black and white, I typically choose black and white. You'll see why here in a few minutes. And we can choose our bitmap fading. So you can see as I change this, more things will show up. Same thing up here with the number of colors. If I go really low, we have the actual image, but now we're going to get all this extra that we don't want in here. So sometimes playing around with these slider bars will really help change what's showing up, especially if the image has a lot of noise in it. There's a noise filter, and that's literally the number of pixels that it's going to try to ignore. So we're going to change this either 1 to 10. I'm going to start with 1. We're going to come down here, and we're going to choose Preview. Now, when we did that, it brings up a black vector line that goes around the whole outside and the inside as well. We're going to hit Apply, and now that locks it in. And we can click on this image and hit the Delete key on the keyboard, and it goes away. And now we have vectors, they're ready to toolpath. In this case, they're grouped, so if we want to make any kind of modification to them, we're probably going to want to ungroup them first. Now we have our dotted lines, and we can put our toolpaths on. What if there's something a little bit more complicated? Let's say we were bringing in a picture, but it had color to it. And let's say we bring in this apple. Now this is a much bigger file. And generally when you're bringing in files, you want them to be big enough to have a lot of detail, but not so big that they overwhelm the program. So typically 2000 pixels by 2000 pixels is a great size to have. If you start getting up to 4000 by 4000, you're gonna run into some issues where it might slow down VCarve. If you go too small, say 200 by 200, you're not gonna have enough pixels to actually get a good image. But we can come back up to the trace bitmap, and that's gonna pull up our different options here. Now we can do black and white. So if all we want is this profile, that's all we have to do. Again, we can change the number of colors, and you can see because of the gradient right there, we're getting part of it cut off depending on how many colors we choose. Same thing with bitmap fading. We can bring it down to none, and we get our vector line right around the outside. But it's possible that our file might have different colors in it, and we want to keep some of those other features. So in this case, we can only choose 16 colors, and we're going to try to choose all of the colors that we want to keep. And you can see as I click them, different things appear or disappear on screen. So in this case, I want this color, I want this color, and I can go through and pick. And say there was a little shiny spot somewhere, we may want to go until we get that color, so we actually get a vector around that color, or leave that color so that there's a contrast between the two. Now again, in black and white, you're going to get the cleanest image. So I'm going to click preview and apply, and then go ahead and close that and delete. And now I've got my vectorized image here. You generally do want to delete them, delete your image after you've delete it after you've vectorized it, primarily because it will slow down the program, and getting that off there frees up a lot of resources, and now I can zoom in and out a lot more quickly than I was before. Well, let's say we were going to bring in something a little bit more complicated than that, say this car. Okay, tiny little car file. We can zoom in here, and we've got a lot of colors that don't have as much contrast on here as we might like. When we vectorize, so we can do black and white, and we're just going to lose this light altogether. We can do color, and we can try selecting different colors, and that may get us better options than we had before. Now in this case, you can see when I select those, there's a lot of noise in this picture. Not too many pixels, so we get a lot of things that are checked, showing up that maybe shouldn't be showing up. So we could vectorize it like this. Of course, we could do black and white as well. Let's say this is what we end up deciding to go with. Apply that. Now, before I delete this image, I want to get this light on the front. And there's a couple ways I could do that. One way, which is most common, is just to use the create arc. And I'm going to start at the beginning and go towards the center. You want to try and find the inflection points where an arc changes direction. So in this case, here and here, and I can try and meet that as close as I can. Now, of course, I could try and mirror this, or I could simply choose the other side of it and try and line that up as best as possible. I can join these two pieces together just by themselves. And if I want, I can come in here to Node Edit and move this one point if I want to make it bigger or smaller. I could also change these into a Bezier curve to get handles and try and smooth some of this out. And I can choose whichever arc I want, whichever point I want, and change this one into a Bezier curve as well. And now that's looking a little bit smoother there. These came out pretty good, but I may also want to decide to stretch these, and I could come in here, ungroup it, and change the node. Or maybe I even just want to replace this with my own circle, just because it's maybe not a perfect circle and I want to get something a little better. I can come in here, draw a circle that's approximately the right size, and just come in here and bump it with the keyboard. Now that lines up pretty well, possibly even a little bit better than VCarve did. And I could do the same thing on the other side as well. Or maybe I even come in here and draw another circle around here, or another arc, depending upon exactly what my design intentions are. When I'm all done, I delete it, and now I have what's left over. Now the other option is to actually import a 3D file. So we're going to come over here, And in this case, I'm going to set it to approximately the size that I want this to be. I'll click OK. I'm going to go to Import Component 3D Model. So VCarve can't draw in 3D, but it can toolpath and cut a 3D file if it's been pre-made. It's got several options here. STL and Lightwave, DXF, SketchUp, Rhino, a few different options. STL is by far the most common. And you can see here there's two options that we prepared earlier. Teleneck, this is what I'm going to be using. And this is just a guitar neck. Now in this case, it's coming in on its side. So we're going to choose back. It's going to put it face down. And we're going to set the size that we want it to be. I want it to be proportional. So I want it to be 24 inches long. Center it on the model. And here's the most critical part of importing a 3D file. We want to change the Z depth, the Z0 plane position. You can see as I move this, it changes what's going to be kept and what's going to be lost. If I have this all the way up, I'm not going to lose anything, but it's also going to be difficult for me to cut this bottom part. If I decide to go all the way up, I'm going to lose everything below the 0 plane. So I could choose somewhere in the middle, but again, I'm going to lose this part of the curve. So this might be something where we actually have to do two different files and two different sets of toolpaths when it's flipped. And we can potentially use VCarve's flipping function for that, double-sided cutting. So when we hit OK, it previews our 3D file. This is what it's going to look like. And we also came over to our modeling tab right here. And we have the option, if we want, to change the scale height, or we can even slice the model into multiple pieces. So say we had a model that was 4 inches tall, but our material was only 1 inch thick. We could slice that into 4 different models, spread that out across our sheet, and then after we cut it out, we could glue it all back together. Go back to the drawing tab and bring out my toolpath menu. And VCarve has two toolpaths that are specific to this type of file, this 3D file. We're going to come to 3D roughing and 3D finishing. So 3D roughing, when we first click that, it brings up a material setup, and we're just going to confirm that yes, we want 1 inch thick, and our Z0 is on the top of the material. Model is all the way there at the top. And rapid Z gaps, we'll get to this all in just a little bit. So we're going to choose our first tool, which is usually an end mill. This is just roughing it out, so we want something relatively large that can hog out this area quickly. And these options for model, material, or selected will depend on exactly what we're trying to do. Generally, you can choose material boundary if your material has been shrunk down to approximately the right size of this piece, which is why I changed the material size. You could choose model boundary if you wanted to keep it completely within this shape, or selected vector if we wanted to go back to the 2D view, add in some vectors, and then make it only toolpath within that area. Now in this case, I'm going to do material boundary because I wanted to cut out this entire area. I'm going to raster the toolpath, and this machining allowance is the minimum amount that it's going to leave between the model and the material it's cutting out. So we're going to do 0.04 as a minimum, raster along the X direction, so it's fastest, because that's the longest. And then when we toolpath it and preview it, we can see this is what it's going to look like if this was the only thing we did. Now, potentially, we could come back into here into edit and adjust the step over. So part of the tool database includes a step over, and every time it drives lengthwise down a part and moves over and comes back, that's a step over. And the default is 40%. That's usually what you're going to run it at. However, with 3D files, making that smaller will make it a little bit more accurate. It'll fit into smaller places and generally take longer as well. So with a roughing pass, we can generally leave it at about 40%, but shrinking that may end up causing us less problems later on when we may not have to do as much on the cleanup tool, on the finishing tool path. So right here, these are the steps we're going to get. And adjusting our step over will also change how deep it goes during each one of those steps. Now that we've done that, we can come back and we can do a finishing tool path. And this is assuming that you've already done the the initial toolpath, that roughing toolpath, because it's going to plunge our next bit as deep as it has to go to create this model. So we want to make sure both that enough material is removed and that this bit can handle it. Typically we'll do that with a ball nose. And if we started with, say, a 1/4 inch bit that tapered down to an 1/8 inch bit, it gives it a little bit more strength than just a pure 1/8 inch bit. So that's what we've selected here. Again, we're going to do material boundary and a raster. Calculate that. This one takes a little longer to calculate. The reason being that our step over for our ball nose should be really small. So let's go ahead and preview just this visible one. And you can see we got a much smoother cut there. So here's where the trade-off on 3D cutting comes in. If we go back into the finishing toolpath and click edit, our step over is at 10%. Now, the reason it looks so smooth here is because we have our preview simulation quality still set to standard. If we had that brought up to some higher number, we're going to see a lot more steps in there. And on the finished product, you're going to see a lot more steps in between. So one way to change that would be to bring it down to, say, 3%. And we're going to do 3 times as many movements back and forth. But we may also be able to do a higher feed rate, so we get some trade-off there because we're putting less load on that bit. So we're going to calculate that, and we're going to see this is going to take a lot longer to calculate here because it's doing 3 times as many movements. If at any point we want to stop this, we can hit this red stop sign and it's going to back out of that and we don't have to continue with it. Generally speaking, if you want to do very little finishing work, very little sanding, you're going to keep this down to 2 or 3, maybe 5% if it's a bigger bit. As you start going up more and more, you'll have to do more sanding work. So let's actually change this back to 10%. So it doesn't take quite so long. We're going to calculate this and see it goes much faster again. And we're going to go ahead, come back here to the summary of all toolpaths, and we can see these 2 toolpaths are going to take about 2.5 hours to complete. So that's one thing about 3D, is that it's going to take a very long time to cut your files. The bigger it gets, the more complicated it is, the smaller your step over, the bigger that number can get. And it's not uncommon to have 10, 15, 20-hour long cuts, which is where the restart on the controller that we looked at earlier is going to come in really handy. You can shut your machine down entirely, it will save all your zeros, and then reboot and restart from where you left off the next day. But I could come back in here and change this to 3%, and we might see this number go up to, say, 6 or 8 hours. So then we have to decide, do we want something that we don't have to do much work to, but will take a lot longer to cut on the machine, or do more finishing work, but save us a whole lot of time. In this case, sanding it would probably take less time than letting the machine cut it out at a really small step over. Now, one last thing we might want to do when we preview everything here, we notice it's still connected to the material. We could come back and we can vectorize this just like we vectorized an image before. So we're going to, again, choose black and white, choose more colors, preview, and we have an outline here as well. Apply. And now we can come back and do a profile cut to finish cutting it out. So we're going to go 0, we're going to cut all the way through, and we're probably going to choose a different tool because a 1/4 inch bit probably can't cut 1 inch deep. We're going to choose outside. And by the way, when we choose outside, that automatically separates inside versus outside toolpaths. So in this case, the holes will cut on the inside and the profile will cut on the outside, even though we choose outside only. And of course, we want ramp in. And we're going to go at least twice the depth that at least twice the length of the material depth. And we can preview that visible one. Now it cuts all the way out. We can get rid of the material. And there's our finished guitar neck. Now, if we wanted to cut the other side, we would do the same thing with the model flipped the opposite direction. The challenge there would be we have to find a way to line it up when we flip it. So we would probably leave off that finishing profile cut, just delete that entirely. And that way we have some kind of a border that we could line up with a jig so we can still reset our 0 or keep that in the same spot. And then we'll cut all the way through on the final pass on the flip side. Now when we go to save this, we save it just like a normal toolpath. Click Save, and because we have a tool changer post-processor, we can put these all in a single toolpath. Go ahead and save that. And we're all done. And now we can cut it. The final option for importing is importing other files, say from Photo VCarve. So there are other programs that Vectric makes, then you can bring those in and use them as well. Same with the vectors. If you had another VCarve file, rather than keeping all of your different drawings that you've ever done in a single file and just bringing them onto the plate, if you need one, you can bring it in and toolpath it and use it again. There's a few other functions of VCarve that I want to go through at the end here. And the first ones are over here under Transform Objects. So the very first option is to move. So besides just clicking and dragging, which I can do, I can also tell a vector to move to a specific location. And I can do the same with the actual 3D part that we've made. I can drag that and move that around anywhere I want as well. I can do a scale, which we went through earlier, just changing the size of the object. And also rotate. So if I want to rotate this 90 degrees, I just hit apply and it will rotate 90 degrees or whatever other number that I want. Also, if you click on the image, you're going to see these little dark squares at the corners, and I can hand rotate using that. Now, of course, the more complex the part, the slower this is going to go. In this case, this is a pretty complex part. But if I choose just these vectors, it's going to rotate pretty smoothly. There's also a mirror tool, which we used earlier for the drill, but there's other options here too. So you can rotate horizontal or vertical. If I uncheck Create Mirrored Copy and rotate horizontal, it's just going to flip it right in its center axis, right there. Same thing with vertical. And of course, I can flip right or left. So that's going to flip it around this bounding box. And of course, I can flip about a line as well. I also have the options for distorting objects. So I can potentially draw multiple lines up and down and have it distort between those two lines. I can choose if it's a single curve or multiple curves. And of course, it's saying I don't have any other curves selected. But it'll try to twist and distort those lines to fit twist the geometry to fit the main line. Down here, there's some other tools that are used a little bit less. There's weld tools, weld, subtract, and overlap. And they're kind of like the interactive trim. So let's say I just go ahead and get rid of all these. Say I put a couple parts on here. And I want to carve out this middle so they all share the same inside. I can use the trim tool, and of course, just draw straight through there. Every time I undo, it undoes one level. But I can also select everything and come over here and do the weld option. And that just gets rid of any shared insides at all. So that makes it really quick. If that's all you want to do, it makes it really, really easy. But I can also do a subtract. When I do that, it's going to leave only certain pieces. And the pieces it's going to leave remaining are based on the order that you select things. So if I choose this one, then this one, then this one, it's going to subtract in a different order than if I choose those in a different pattern. If I choose the center one, then the bottom, then the top, it's going to go in a different, or in this case, the same order. Sometimes it's different. If I grab the whole thing just using VCarve, just grab a selection box, I guess it's doing the same thing. Sometimes it'll do different options, different orders, like that. So I selected all three of them and it shows them in a different order, which is why I tend to use the interactive trim first, because it will choose them in the order that I want them to be chosen in. We also have the option of overlap. So if we have something that's common to all the parts, it's going to keep them. But again, the order that you select them will change. Maybe I want both this one and this one, or just this one. That's where the trim really comes in handy. The other options down here are fillet. So if I wanted these to be rounded corners, I can come in here and choose a normal fillet of a certain radius and just click on each corner that I want to be a fillet. But there's other options here too, like dog bone and T-bone. and plasma. So if you have a plasma machine, you can also use VCarve for that. There's a totally different post processor to use, so when you're saving it, you save it with a different post. But I can always do those after the fact. Now if I wanted the inside curves like I had before, I would maybe have to come back here and use the trim tool to get rid of those, and now I have that inside fillet. The next tool is the extend tool. If I have two lines that are separated, I can use the extend tool, and based on which side of this line I'm choosing, it extends it in that direction. Then when I choose the other one, it will not only extend them together, but automatically trim them, so I don't have to do any other work at all. And there's another similar tool to that, if I draw two more lines, which is the join close. So if I grab both of those and join close with a straight line, it just puts a straight line going between the two. I can also join close with a curve, and it does its best to put an arc in between there. Or I can join close by snapping the 2 points together. There's also a curve fit. So if I have a part that I've imported and traced, but it doesn't come out very smooth, maybe I have a lot of very small jagged lines going across it, I can use this curve fit to try and fit a smooth curve to this. So depending upon the size of the part, I may have to change this tolerance. Now normally you're going to be in a very small tolerance like 0.1, 0.01. In this case, I might change that to say 5 inches, and it's going to smooth them out just because I have a pretty big part. But that will tend to create a smoother curve so you don't get a lot of back and forth when you're importing parts. I can cancel it and back out as well. There's also a measurement tool. So if I want to come through and measure what the gap is here, I can see either the distance, in this case it's 8 inches between these two parts, or I can come down to a span, and if I click on one, it tells me what that span is. So in this case, it's 5.4 inches long, but if I add both of these together, the total vector is 10.6 inches long. Because it's an open vector, it just says open vector, so there's no area to be shown there. Also down the bottom here, we have a circular copy and a copy of long vectors. So if I have a circle tool to use, and I want to place that circle a certain number of times along this line, I can do that here. Copy object, and I can say I want 7 of them, or I can say I want a certain spacing between them. And we're going to say copy, and it's just going to fill them out across this whole shape. And that's really useful for making flanges. We can make a flange very easily if we put a circle, say it's center, and make 6-inch diameter. Maybe we want a center hole at say 1-inch diameter. And then if we want circles to loop around, say at 3 inches out, we're going to put in 3 and put the circle where we want it to start. Now we can use these two, and the order that we select them determines which one gets mapped around the other. Come to copy along vectors, again tell it the number of copies we want, and it fills them out. Now if we had an even number, one thing to be careful of, and we hit copy, it's going to place that last one on top of the first one, and we're actually going to have 2 separate lines here. We'll see that because if we click this and hit delete, we still have a line there. Now if we hit delete again, it goes away. So that's one thing just to watch out for if you're doing even numbers of things. But there's also, if we back out of this, get rid of all these, there's also a circular copy. So you can create an array of that many parts. You just tell it where you want the center to be, in this case 0, 0, and we want 12 of them. And we can copy them and it just fills that out. So I wouldn't even necessarily have to have that center line. Now on the other side, we have the toolpath menu, and there's a few remaining toolpaths. Starting with version 10.5, they added thread milling. And this is going to be very specific based on the thread milling bit that you get. But if you have a bigger hole, something like a 1-inch or 2-inch hole that's maybe too big to run a tap through, you can buy thread milling bits specifically, fill out all this information in terms of the start depth and the end depth, thread length, pitch and which direction you're going, internal or external, and it'll end up creating that thread for you. We have a quick engrave function, and that's basically if we create a shape and we want to just hatch fill that very quickly, we can hit calculate, reset this, and it's just going to create a very quick hatch fill without doing any extra work. So it makes it really easy there. Our inlay toolpath is used a lot for signs. So if you have two different parts for the sign, you have the outside part and the inside part. Maybe the inside's acrylic backlit, and the outside's aluminum. You can use this inlay tool. So maybe I have this here, and this text tool, this draw text, lets me fill in text within a box, and as I type, it fills it in and keeps it inside that box. So let's say I wanted to type ShopSabre there, and maybe the ShopSabre part was going to pass through, and then this border was going to be made out of a different material. Well, I could just toolpath this with two different toolpaths, inside and outside, profile cuts. But the problem there is that the inside cuts are going to have a rounded edge because the bit is round, but the outside is going to end up having a square edge. So what this toolpath has done, this inlay toolpath, it's brought both of those into a single option. I have a male inlay and a female inlay, and I can choose which one I want. It's going to automatically round those corners, and you can give a tolerance as well, say an allowance offset, so it keeps enough gap there where you can slide the parts in between without having to grind them down or sand them down first. And if we choose the stepped option, it also gives us an option around the edges to create a little step where that letter will no longer slide all the way through the part, it'll stop at the back. And if we have these joined together close enough, it may just create one big step all the way around, so we keep it as a single piece. Another option that's new with 10.5 is photo V-carving. And that used to be a completely separate program that Vectric made. Now they've integrated into VCarve. And if we bring in another part here real quick, let's actually bring in a bitmap. We're going to choose, let's say this duck. That duck's a good example. We're going to bring this over here, and we're going to put a vector on it. Before we do that, we're going to come over here to our photo VCarve. We're going to give it the maximum carving depth, how far it's retracting, and what bit we're using. And we're going to either raster or hatch fill. Calculate that. We have to select the bitmap first. And we're going to preview all. Now this is going to change based on how the light hits it. So if the light hits it in one way, it'll be real dark. If it hits it the other way, it'll be real light. And that's a really simple way to get a quick carving there. You can see that won't even take all that long, 20 minutes, and you get that nice image. Now, of course, I can vectorize this as well, and you may end up seeing, depending upon the contrast, that we get some of these little areas in here. Now, in this case, the rest of this seemed to have come out pretty smooth, but perhaps down here is where I would take that arc tool and come along and smooth it out. Another option is the fluting tool. So if you're doing flutes on columns, you can make a ramp that will get deeper on one side. Starting on one side, just literally diving deeper as it goes along, or creating different shapes you can see right here. That's not used quite as much. And what's really taken it over now is the molding toolpath. So what we can do is make two different, we have to get out of this tool first. We can make two different paths. Let's say I want something that's an arc across here, and I want that to go across this whole distance, like this. Let me go ahead and delete this toolpath here. I can choose my molding toolpath and choose these two options, and you can see it puts one of them along the other one. The order that you select these in is going to change which way it gets cut. Now in this case, it's saying cut depth exceeds thickness. What we can do is come into node edit mode here. If we close out of this, come into node edit mode, and we can change the direction that these go. You can see the green is the start point. We're going to go make start point and select these in this order and calculate. Now in this case, it's saying that it can't fit the entire toolpath across there. So that's going to be based on the order that we're selecting these. Calculate. Now it's going a little bit too deep, but that's okay for this. Reset and preview. And it's going to end up cutting in a circular motion. Now let's redo that. I want something. That's why. All right, I'm gonna start over with it. All right, so let's say I want this arc, and I want it to be spread across this whole face, or some part of this face. I'm going to draw the length that I want it to cut along, and the profile that I want it to take. And the order that I select these is going to determine which one gets placed across the other, which direction it cuts. So if I choose the length and then the shape, you can see it's going to profile cut this way. If I choose it in the other order, it's going to try to wrap this long line across this arc. Now in this case, because it's going to go the wrong direction, we want to change which direction it's starting from. We can come in here to the node edit mode. We can change our start point and go back into our toolpath, selecting these in the appropriate order. And now you can see it's going to cut that way. We choose our tool, which is usually going to be a ball nose, calculate, reset and preview. And now we have a nice curve that goes along that path. That one is really handy for anything from door moldings to making bowls. Anything that needs a curve that can be symmetric, that works really well for creating a 3D file from. There's also a texturing toolpath. So if we get rid of this, we make just a nice box here. We want to put a texture in, maybe something that looks similar to wood grain. We're going to come back over here, texturing toolpath, select our box, choose our tool, and all these different options here will change how it looks. There's a couple of defaults. So let's just say default. We're going to choose calculate. This might take a minute depending upon the size of the shape that you're creating. We'll reset this and preview all. Now you can see it created a nice little bumpy texture in there. And it's a little bit different than this vector texture. And if you play around with this just right, you can make it look like real wood sometimes. And there's also a prism carving toolpath. So let's just say that we wanted, say, a circle like this. We put a prism on it, calculate that. In this case, it's saying that we have to go deeper, and so it may not work quite as we wanted, but we're going to preview that. This is what a prism toolpath does. You can see it's going to put angled lines around any lines that it sees. So if I had wording on here, say I had the word prism, it's kind of like a V-carving toolpath. Nope. Let's grab that there. There we go. And we'll just recalculate this prism. It creates these little prismatic shapes. So if you wanted just, say, the raised letter P that kind of met at a point here, you could cut all the way through it with a V-bit, and you'd get just that P all by itself. There's also the option for chamfer, and that's new in 10.5. Before, you actually had to go up to this gadgets section and do a chamfer, but now they have it just as a toolpath. So I can create a line, I can tell it I want to do a chamfer at whatever start depth, whatever bit I'm using, and the angle and cut depth and width, and it gives you all those options here, inside or outside, and you can calculate it, and it's going to do a chamfer with those particular settings. In this case, I did a pretty small chamfer, but it's going to slowly carve down one direction or the other based on how you set it up. Also here is the tool database, and this is something that needs to be set up when you first get your machine and first get all your bits. You're going to go ahead and program all these bits in here. You can come down here to add a tool, and whichever section I'm in, that's the section that's going to add it in. So I can say add an end mill, and maybe I have a 3/8 bit that's made specifically for aluminum. So I can type aluminum, or I can come up here to ball nose and put it in the name here rather than in the description. And now it'll show up out here. Give it the diameter, the number of flutes, and create. And I can lay all these settings out as the manufacturer recommends. And this is something you want to talk to the manufacturer about because every bit manufacturer is going to be different. Some manufacturers will have a chip load for the exact same size and type of tool that's half as much as another manufacturer, so you may have to go half the feed rate. And that's really important to know. So this chip load is a combination of this feed rate, the spindle speed, and how many flutes you have. And you want this to be what the manufacturer says. Plunge rate is almost always half of whatever your feed rate is. And if you have an automatic tool changer, you want to make sure that tool number is correct. If you don't have an automatic tool changer, you can have them all as one and it won't matter. You can also create groups of tools down here. So if I have a 5-position tool changer, I can have 5 tools that go in as a group when I'm doing wood signs, and then another 5 that go in when I'm doing aluminum, and another 5 that come in if I'm doing a braille sign. And I can keep those as groups together. I can copy them, I can import them. So if I have multiple computers that have VCarve on, I can import and export those. And of course I can delete what's already there. All right, so I can hit OK. And the one big thing if you have a tool changer with that is you want to make sure that those tools match what's on the machine. Although the machine itself may not care what tool is where. If it calls for tool 3, it's going to go grab tool 3, but you want those tools to be in the correct spot so it grabs the correct tool. There's also the preview, save template. So if you have the same set of tool paths that you're using over and over and over, you can save it as a template and load those up so you don't have to reload all of these exact same settings and change them every single time. Additionally, there's duplicate. So if you want to make the same toolpath multiple times, create a job sheet. So if you have something that's too big to fit on a single sheet, you can automatically split that into multiple jobs. And tile toolpath, that's how you're going to do this. If you'll put in the tile width and tile height. So if you had a 48 by 96 sheet, you can create sheets that are, say, twice that big or half that big. If you had a 24 by 48 sheet and you wanted to split it into 4. Update the tiles, and it's just going to split those tool paths across those different sheets. Under material setup, the thickness, the XY0 and the Z0 are very critical. If you set your Z0 at the top of the material, you can control the exact depth of your cut. So if you have a material that may vary in thickness, say you've got MDF that says it's 0.75 normal, but it could be 0.74, 0.76, and you care about exactly how deep you're going, this is where you might want to go from the top of the material. It's also easier to set and change your Z0, so you can easily get to that rather than having to move the material and get to the bottom. With the Z0 at the bottom, machine bed, or most likely your spoil board, you're going to have more accurate material remaining. So you can cut down regardless of how thick the material is, it will leave that amount there. And it's also overall maybe faster because you can set your Z0 once and you'll never have to change it until you re-fly cut your spoil board. It'll always stay the same and the machine will remember that. One of the most important things though is down here in the rapid Z gap. That's how high off the top of the material that your bit is going to travel when it's doing rapid moves. That's important. It's not based on the thickness of the material, it's off the top of the material, regardless of where you put your Z0. So if you have clamps, make sure that those numbers are high enough that they can clear those clamps without hitting them. But if you have a smaller machine, like a ShopSabre 23, where you're limited on Z height, you want to make sure that's low enough that you're not getting soft limit exceeded Z plus errors because it's trying to lift too high. And that's one of the most common reasons you might get a soft limit error on the Z. Plunge is the distance above the material that it's going to start moving at the plunge speed. So it's going to rapid down at full speed until it gets to the plunge depth. Then it will start moving at the plunge speed that we programmed in to our toolpath down here in the plunge rate, which is usually half the feed rate. A few other random things in VCarve here, we have guidelines. So if we just grab and click on one of the rulers, we can pull those out. We can put them wherever we want. We can right click on those and change the angle that they're at. And again, we can grab them around, move them around. We can click and drag off the sheet, or we can right click and just delete the guideline altogether. But if we have parts or drawings that we're making, we can snap directly to that guideline. The snap tools are up here. If we toggle these snaps off, then let's say we have another part, it won't snap to those endpoints at all. But if we turn them back on, we can snap directly to them. There's also some zoom tools. If you don't want to use the mouse wheel, you can use these different zoom tools here to zoom to the whole plate or some section that you click and drag a box for. And gadgets are things that you can add into VCarve, and you can download those from the Vectric website. You do have to make sure that you're getting ones that work with your version. There are specific versions of the software, and Aspire, which is VCarve's big brother, has some gadgets that won't work with VCarve, so you have to make sure you get the right ones. But by default, you have a drag knife toolpath. So if you have something like a Donic drag knife where you're just plunging that and then driving it along and doing little loops in the corners, you would use that drag knife and it'll automatically put those loops in. If you had a keyhole tool, say you're making keyholes, or if you're making a cribbage board, the backside of the cribbage board where it has to make that little slot, it will plunge, go in, then come back out the same location it went down in. And that's all built in here. There's also an explode gadget. So if I have some shape, but I don't want the rest of these, I just want to be able to click on that top line, I can explode it. It'll ask me if I want to replace and put them on a new layer. In this case, I want them on the same layer. And now when I click on one, it's separate from everything else. There's also a wrapping toolpath, which is less necessary now. Starting in version 9.5, they added double-sided machining, and one of those versions also added rotary toolpathing. So if you have a fourth axis, that's all now built into VCarve, where you just tell it the length and the diameter, you draw on the flat, and then it rotates it around. You just have to make sure that you know which direction along the X or the Y that it's facing. And for flipping parts, I recommend referring to VCarve's video on double-sided machining. They do a really good job at showing you the dowel method so that when you flip, those dowels stay in the same spot. The pop-up reference pins on the machine, not necessarily accurate enough when they have material hitting them all the time. Sometimes they can move just ever so slightly out of position. For a normal file that you're cutting, that won't matter at all. But when you're flipping the part, being off even 1/1000th of an inch, could cause an issue. So using that dowel method is really the best option. You just have to make sure you specify which direction you're flipping it. And once you choose a double-sided file, up at the top you have toggle bottom and top side. So when you draw something and then flip it, it's going to make a very light gray outline, and the rulers are going to change color so you know that you're on the opposite side. And this is what we drew on the other side. Now if we draw on this side and flip back and forth, it shows it like that, and the toolpaths disappear because the toolpaths are side specific. In the help menu, there's also a set of keyboard shortcuts and a video tutorial browser that will bring you to their set of videos, which are included locally on your PC. You don't have to be on the internet to see those. And it'll bring those up, and you can watch any of the things getting started all the way through doing all the toolpaths that we talked about here. All right, to wrap up this video, I figured I'd take you through some of the maintenance items that you can expect to keep the machine running in tip-top condition. Every machine is going to be a little bit different depending upon the number of bearings and ball screws or rack and pinion that you have, and the other options like a vacuum pump might also play into it as well. So to start off, I figured I'd bring you into our manual, and in Chapter 2, the very last section is lubrication. So here, it shows 3 pictures on the bottom and talks a little bit about what you can expect in terms of how many grease points. Most machines, like Pros and ISs, are going to have 16 grease points. You're going to have 12 linear bearings and 4 ball nuts that go around those ball screws. All of them have to be greased roughly every 40 to 60 hours of runtime. But the most important thing is that there's a small amount of grease on the rails at all time. If it's completely dry, you may want to increase your greasing schedule. If you're getting grease coming out of the seals of the bearings or ball nuts, you're going to want to pull back on that, or you could have a clog, which you may clean out with some WD-40. If you're doing that, spray some WD along the rails, run the machine back and forth. That'll remove all that old grease, and then re-grease it with the new grease. So typically 1 to 3 pumps on most ball nuts every 40, 60 hours. But if they're completely bone dry, some of those ball nuts can take 10 to 15 or more pumps of grease from empty. So just be aware of that. And if you grease it while it's in motion, as it's moving, it'll start moving grease out the back of the nut or the bearing. So while it's in motion, you can pump until the grease comes out of the back and you don't have to worry about blowing out seals. If it's stationary, those seals could blow out if you pump too much grease into them. So a good way to get it in motion, if you're all by yourself, move it to the back of the machine and hit the home button. As it's coming forward or to the left, you can stand there and grease it as it's going along. If you have someone else there to help you, put it in slow motion and have them drive it while you grease it. Now, if you have an RC machine or a 23, it'll be a little bit different because you only have 3 ball screws on a 23, and you may only have 2 bearings on the Z-axis. The ball screws on the 23 don't have zerks on the ball nuts. So you just lay a bead of grease right along the screw and you'll be good to go there. Same thing with the rack and pinion on an RC series or Sidekick series. Just run a bead of grease along the teeth and you're good to go. So make sure that you use the needle fitting when you're greasing those. A standard grease gun may get stuck on those zerks, and if you pull too hard, it can pull the grease zerk out of the bearing, and because they're just threaded into plastic, and then you have to get a new bearing. So if you use the needle fitting, you can just push that right up against the check valve at the end of that grease zerk and pump grease in. If you get grease coming out between the needle fitting and the grease zerk, then you don't have a good enough seal, and if it's coming out of the seal, that's too much grease. But again, greasing while in motion will help that. Now, other items have different maintenance levels. If we come back into the vacuums, we see one option is the F4 vacuum, and the F4 has brushed motors. So in the manual, we show you how to change those. They say to change them about every 750 hours from the manufacturer, or to check them every 750 hours at least. Sometimes, depending upon their use, if you're only using 1 motor at a time or 2 motors at a time, you may be able to get 1,500 hours out of them. So just keep track that way, and that counter that we showed at the very beginning on the ShopSabre will keep track of how long the machine's been running as well. So this shows exactly how to change those. Scrolling back up, we also have FPZs and we have Becker pumps, and their information is all in the manual as to how to do maintenance to them. The biggest thing with those is that they all have a filter, and you want to keep that filter clean. They both show how to change those filters, but primarily on the Becker, it's actually in the side of the Becker, so you're just going to unscrew that, take it out, clean it about every 40 to 200 hours, depending upon the amount of use. And the FPZ has a separate canister filter that should be taken out and changed about the same amount of time, 40 to 200 hours. On the Becker, there's also a small amount of grease that you'll want to apply, and that comes right with the Becker. About every 3,000 hours, this special grease, which is shown, should be put in there, and you'll also want to check the blades on the Becker, on the motor itself, just to make sure that those blades are the correct size. All right, so in this video, we went through all the features of the controller and actually running the machine and getting the machine set up to cut, going through all of VCarve and getting that first part actually out to the machine, and then actually out there cutting the machine and through all the maintenance you need to keep the machine running for a long time. So I hope that really helps you get out there and make your first part.
Well, I hope you enjoyed the video. We tried to include the same information in this virtual training class that you would experience if you visited our Lakeville, Minnesota manufacturing facility. If you'd like to see more videos like this, be sure and subscribe to our YouTube channel. If you need more information, you can contact us at ShopSabre.com. Thank you for watching.